Well, welcome. In this video, we're going to be looking at trigonometric ratios in right triangles. Now, this lesson is the beginning of Chapter 5, a brand new chapter. In the previous chapter, we were dealing with trigonometry, but it was mostly looking at, we looked at the graph translation theorem, we looked at the graphs, the sine, the cosine, the tangent functions, we looked at the unit circle. This chapter is going to be looking at more of the more hands-on uses of trigonometry, of where we could use this more in a lot more real-world applications. In fact, I even just used it just this past summer. But basically, we're going to be looking today at the trigonometric ratios and how they relate to a right triangle. So let's start out by reviewing a right triangle. So you can look here to my right, and I have a right triangle. And remember that on a right triangle, obviously, we have a right angle. The side across from that right angle is always going to be the hypotenuse, and that's always going to be true. Okay, on a right triangle, the longest side is the side across from the right angle. Now, the other two sides are going to be called either the adjacent leg or the opposite leg, depending on the angle that we're looking at. So in this example here, if I was looking at angle A, the side across from angle A would be that side BC, where the side adjacent to angle A would be the side AC. But it doesn't matter that we're looking at angle A, the hypotenuse will remain the side AB. Now, let's say if I was looking at angle B. Now my opposite and adjacent legs are going to switch. So now my opposite leg would be the side AC, and my adjacent leg would be the side BC. So you can see that the adjacent leg and the opposite leg change depending on what angle we're looking at, but the hypotenuse will always stay the same. Now, the purpose of this lesson, the point of this lesson is to look at the trigonometric ratios. Now, the trigonometric ratios only work with the right triangle. If we're not working with the right triangle, then we're going to have to do something different called either the law of sines or the law of cosines, which we look at in future videos. But again, so for this lesson, it's important to know that the sine, the cosine, the tangent, the ratios that we're going to be working with only work with the right triangle. So what are those ratios? Well, let's look at those now. So here we have our ratios. The ratios, again, are the sine, cosine, and tangent. Now, a ratio, remember, is looking at a fraction. In this case, our ratio for the sine function is that it's the opposite leg over the hypotenuse. So it's the opposite over the hypotenuse for the sine function. The cosine function, then, is the adjacent leg over the hypotenuse. So we look at what side is adjacent to the angle, divide that by the hypotenuse, that will give you the cosine of the angle. And lastly, the tangent of an angle is not always the largest number divided by the smallest number for your legs. It's always the opposite leg divided by the adjacent leg. Now we have a phrase to help us remember these trigonometric ratios. That phrase is so, ka, toa. So, being the sine is the opposite over the hypotenuse, ka is that the adjacent, or is the cosine is equal to the adjacent over the hypotenuse, and toa is that the tan, or the tangent, is equal to the opposite over the adjacent legs. So let's look now how we use these trigonometric ratios in some story problems. Okay, now sometimes they're going to give us a diagram and sometimes they're not. And this is one of those situations where they don't give us a diagram. So that's going to be the first thing we start out with doing. It says in triangle ABC, angle C is a right angle. The opposite A has length 20. The leg adjacent to A has length 21. And the hypotenuse has a length 29. We want to calculate the sine, the cosine, and tangent of angle A. Now again, to start out with, to help us out here, I'm going to create a right triangle. Now we're going to use this as a reference. So the only thing that's important is to make sure that we have the correct angle as our right angle. So in triangle ABC, it says angle C is a right triangle, is the right angle. So now it doesn't matter as far as A and B, because again, we're only using this as a reference. So if it just so happened that AB or AC was the shorter leg and BC was supposed to be longer, it's not a big deal, because again, we're just using this as a reference. But now let's use this to fill in the information that they gave us. So they say that the leg opposite angle A is 20. So here's angle A. So the leg opposite of that is 20. The leg adjacent to angle A has a length of 21, and the hypotenuse has a length of 29. So now we're going to use this information to find the sine, the cosine, and tangent of A. Now, when they ask us this, they're asking for the ratios for the sine of A and the ratio for the cosine of A and the tangent for the ratio for the tangent of A. So the way that we figure that out is, again, using that phrase SOHCAHTOA. So sine is equal to the opposite, so the sine of an angle is equal to the opposite over the hypotenuse. So the opposite leg is 20, the hypotenuse is 29. The cosine of the angle is equal to the adjacent over the hypotenuse. So this would be 21 over 29. And lastly, the tangent of the angle, the tangent of the angle is the opposite over the adjacent. So in this case, the opposite leg is 20 and the adjacent leg is 21. So this would be the sine, cosine, and tangent of angle A. Now let's look at the next one. The next one we're dealing with triangle DEF, where angle D is the right angle. And then it says, so let's label these D, let's label this one E and this one F. So then it says DF is 40. So this one here is 40. And EF is 41. Well, that's all they give me there. We're missing this side. We're trying to figure out what's the side F. It's called side F, by the way, because it's across from angle F. Or you could say it's side ED. Both would be right. But if you're thinking that maybe we should use the Pythagorean theorem, you're thinking correctly. Because that is exactly what we need to do. The Pythagorean theorem only works with right triangles, and that's what we have. And we can use the Pythagorean theorem if we know two sides, and there's one side of the triangle that's missing, which is what we have here. So remember, the Pythagorean theorem is a squared plus b squared equals c squared. Well, a in this case we'll use as our f, so we'll say a squared or f squared, plus b we'll use as our 40, so that'll be 40 squared, and our hypotenuse is always going to be our value for c, so that'll be 41 squared. Now the way that I'm going to do this one, instead of expanding these out and having to work with some really large numbers, I'm just going to take on my calculator, I'm going to get the a squared by itself. So I'm going to subtract 40 squared from 41 squared. And when I do that, I get 81 as my answer. So now I'm going to have to take the square root of both sides, and the square root of 81 is 9. Now technically it would be 9 and negative 9 that I could square to get 81, but our side lengths are only going to be positive values, so our value here would be 9. So now I can find the sine, cosine, and tangent of E. So the sine of E would be the opposite over hypotenuse, which is 40 over 41. The cosine of E is going to be the adjacent over the hypotenuse, so that's going to be 9 over 41. The tangent of E is going to be the opposite over the adjacent, so we get 40 over 9. And that would be your answer. Let's look at some other more applicable situations for the sine, cosine, and tangent. So let's look at this one here. It says sonar in a salvage boat locates an object at a downward angle of 50 degrees and a distance of 510 meters as shown in the drawing. How far below the level of the water is the object? So here it appears that that object is a giant shark, but we don't know what that object is. But we're trying to figure out what is the depth of that object, the vertical depth there. So to figure that out, I'm going to look at my diagram here, and I'm going to see with the information they've given me how each of these sides relate to the angle. So this side here is opposite that angle. This side here is across from my right angle. It's the longest side, so that is my hypotenuse. So now that I know this information, I can think about which trigonometric ratio uses the opposite and hypotenuse. Well, if you're thinking the cosine function, you're wrong. You should be thinking of the sine function. The sine function uses the opposite and hypotenuse. So we would have the sine of the angle. Now this time I know the angle. The sine of 50 degrees is the way I'll set this up. Equals the opposite, which is d, divided by the hypotenuse, which is 510. Now the way I'm going to solve this is there's a couple ways we could look at this. We could look at this as a proportion and cross multiply. Or you could look at it as just we want to get the d by itself, so we multiply both sides by 510. Either way, you're going to get the correct answer. So let's look at this as cross multiplication though. So 1 times d would just give me d. And then on the other side of my equal sign, I'm going to have 510 times the sine of 50. Now we're going to do this on our calculators, so let's get those calculators out. Now one of the first things we want to do is you want to make sure that your calculator is in degree mode. Now a lot of the previous chapter we had it in radian mode, so you want to go back to this screen and you want to make sure that if your calculator is in radians, you want to make sure that we change it to degrees. And then make that your default. Don't just hit enter or don't just hit OK. We're going to make that our default, so anytime we open up a new document, it'll automatically be set to degrees. If we need to change it to radians, we can easily do that. Well, let's go to a calculator screen and just review how we access our trig functions. So for this one here, we're going to take 510 times the sine of 50 degrees. So to access the sine, we're going to look at the trig function right here. And there it is. And then we're going to type in the sine of 50 and hit enter, and we get our answer of about 390.7, and this would be meters, 390.7 meters or 391 meters. And that would be our answer. So let's look at this next one. This next one, they don't have a diagram for us. We're going to have to create our own diagram. Okay, I know that's not a great kite. Was not blessed in my family with all the art skills. That was my brother. But let's just say this is us flying a kite, and it says that we have a friend that's going to be standing underneath the kite. So here's your friend, and here's the triangle that's being made. There's your right triangle. So it says we have let's fill out our information here. It says that we have a 60-meter long string kite, so this is going to be 60. And it says that it makes an angle of 68 degrees with the ground. Now I know we're not holding this kite against the ground, but if you were to extend out this angle down here would be 68 degrees. Well, using what we learned about in geometry, that means this angle here is also 68 degrees. And so the information we're trying to figure out is how far away from our friend are we standing. So this is where we're going to use one of those trigonometric ratios. So we got to ask ourselves now, how do these sides relate to the angle to figure out which ratio we would use. And we can see that we're using the adjacent leg and the hypotenuse. So that tells me I should use the cosine function. So it's going to be the cosine of 68 degrees equals the adjacent leg over the hypotenuse. So now if I cross multiply, I'm going to get x equals 60 times the cosine of 68 degrees. And if you do that on your calculator, we should get 22.5 as our answer. So this would be 22.5 meters. Now, we have two terms that we're going to be talking about. Now, the textbook definition is pretty wordy. I think you can make it the most sense out of just looking at the diagrams. So in that previous example where we were in the boat looking down at an object, that's what we call our angle of depression. Where with this one, where we're looking up at the kite, that's our angle of elevation. An easy way to keep it straight is if you're looking straight across and then look down, that's your angle of depression. So if you think about if you're depressed, you found out your dog just died, you failed your test, your girlfriend broke up with you, or your boyfriend broke up with you, you're looking straight across, well now you're depressed, so now you're going to drop your head down. I know that's something fun to think about, but it'll help you remember what the angle of depression is. Angle of elevation, that's formed when you look straight across and then look up at an object. So that is our angle of elevation. Well, let's end by looking at a couple of more examples. Let's say if this is a problem that we're working on, you wonder how tall a grain silo is. You walk 60 feet from the silo and find that you have to look up at a 38-degree angle to see the top. If your eyes are 5 feet 3 inches off the ground, how tall is the silo without the roof? Now you might wonder, I don't think that I'd ever do this. Well, there's plenty of situations though where this would come in handy. For example, this summer I bought my nephews a rocket launcher. And this rocket was done by air compression, and they were wondering how far their rocket was going up in the air. Well, I was able to use an app on my phone which allows me to find a level, whether or not something's level or not. And it also gave the degree angle as if my cell phone was tipped. So I use the edge of my cell phone to line up with, so I stood a certain distance away from the rocket being launched. And I was able to use the edge of my cell phone then to figure out the angle of elevation that the rocket was reaching at its highest point. And then I was able to use my distance that I was standing away from the rocket to figure out how high the rocket was going. And we were able to figure out that after doing it a bunch of times and averaging the numbers together, that it was going up about 200 feet in the air. So that is how we can use trigonometry in real life. So here we're going to use it for figuring out how tall a grain silo is. So let's say this is the silo, and this is us standing a certain distance away. And the angle of elevation is 38 degrees here. Now when we find the height, we're only finding the height from our line of sight to the top of the object. We have to take into consideration the fact that we are 5 feet 3 inches tall. So we're going to add that in at the end of our answer. So let's first figure out what our value for x would be. So we know that we're standing 60 feet away from that silo. So using this information, we would use the tangent of the angle. So the tangent of 38 degrees equals x over 60. So to figure out what x equals, we're going to take 60 times the tangent of 38 degrees. And when you do that on your calculator, you get 46.88 feet, or 46.9 feet. Well, what we're going to do now is we're going to add to that our height, because remember, this is going from the ground to our eye height, basically, is 5 feet 3 inches. Well, here we have a problem. 46.88 is written as a decimal, and here where this is written as in green, that's written in feet and inches. So I have two options. I could convert the 46.88 to be in feet and inches. Now, it is not 46 feet and 88 inches. It's 46 feet and 0.88 of another foot, or just under 9/10 of a foot. So I could convert that to inches, or I could convert the 5 feet 3 inches into a decimal, which is what I'm going to do. Because 3 inches is the same as 3/12 of a foot, and that does a decimal is 0.25. So this is the same as 5.25 feet. Add those together, and we end up getting approximately 52.1 feet. And that's your answer. Okay, I want you guys to try this one on your own. It says from a height of 5 feet 6 inches off the ground, a person looks up 30 degrees to see the top of the flagpole. The person then walks 85 feet to the base of the flagpole. How tall is the flagpole? So I want you guys to try this one on your own. So why don't you hit pause and hit play when you're ready to check to see if you have the correct answer. Okay, you should have gotten 54.6 feet as your answer, because if you can see from your diagram, we're trying to find the height from the for the flagpole from our line of sight up to the top of that flagpole, and then we're going to add to that our height, which is 5 feet 6 inches. So you end up getting 49.07, but then, like I said, you have to add 5 feet 6 inches, which is the same as 5.5 feet, to get approximately 54.6 feet as the height of our flagpole. Now, all of the examples we've been looking at have been looking at situations where the numerator is our missing value. We're going to look at one more. We're going to skip 4a and we're going to go to 4b. And we're going to see what happens in a situation where our denominator is the missing value. So with this one, it says a roof of a house is slanted at an angle of 28 degrees to the horizontal. If the roof ends at a side of the house 22 feet above the ground, how long would the extension of the roof be if the roof were extended all the way to the ground? So here's what we have. We have a house. Now technically, this angle here is 28 degrees. Well, look at what the other information that they gave us. So it says that it ends at a house, or at the edge of a house 22 feet above the ground. So this distance here is 22 feet. And then it says if we were to extend that roof to the ground, what would the length of that roof be? So we're trying to figure out this length. Well, if we extended that to the ground, these two angles would be the same. So this is also going to be 28 degrees. So this would be the triangle we're working with. So we notice that we're using the opposite leg in the hypotenuse. We're going to use the sine of the angle. But now, here's where you got to be careful. X is in the denominator. Do not think that we should divide both sides by 22 to get our answer. That would be wrong. In reality, what we're doing, remember at the beginning we looked at this as a proportion. So when I multiply these two together, I would get, when I multiply these across from each other, I would get x times the sine of 28 equals, and 22 times 1 is 22. If I divide both sides by the sine of 28, I get x equals 22 divided by the sine of 28. So that's going to give us our answer. And if you plug that in on your calculator, you get your answer of 46.9, which would be 46.9 feet approximately. So there you have it. That is how we use trigonometric ratios in some real-world applications, whether or not you think you would use these particular situations. There are plenty of applications. And now hopefully you understand this. And good luck now as you work on your assignment.